Hello once again. Here we are at 11.2. We are going to look at finding the area of a sector of a circle. So the first thing we want to start with is what actually is a sector of a circle. Well, essentially you have your circle and a sector is like just a piece of the pie. Okay, so like this area right in here is a sector of a circle. And what we're going to do is we're going to figure out how to find the area of just that part of the circle. And of course, we know how to find the area of a whole circle, so finding the area of a part of it is not going to be too tough. And thinking back to when you did the Khan Academy videos, the area of a circle is just area equals pi r squared. We do not have a formula that has anything to do with diameter this time. Strictly have to be working with radius. So anytime you have anything talking about a diameter, just make sure you think about the radius is half the diameter, or that the diameter is 2 times the radius. So if we needed to figure out the area here of some different things, we have the area of a circle with a radius of 9. Well, again, kind of like the last video, I like to write my formula first, pi r squared. And I know it tells me that the radius is 9 inches, so I'd have pi times 9 squared. Of course, we always make sure we do exponents before we multiply. So our area is going to be 9 squared, which is 81 times pi. And 81 times pi, again, we need to make sure we're using the pi button on our calculator that has the whole decimal on it. 81 times pi is 254.47 or 0.47. And in this case, we are in inches. And when we do area, it is labeled as inches squared because it is how many square inches will fit in there. So the area of a circle with a diameter of 8 feet. Again, we don't want to use diameter. We need to use radius. So we know if it has a diameter of 8, it has a radius of 4. And if we need to find our formula again is pi r squared. So we have area equals pi times 4 squared, which is 16 pi, because 4 squared is 16. And 16 times pi is 50.27. And we are talking about feet, so it would be feet squared. All right, next it asks what is the radius if it has a area of 100. Okay, well, again, we have area equals pi r squared. Tells us the area is 100, so instead of a, we're going to have 100 equals pi r squared. Well, we need to get r by itself, so I'm going to divide both sides by pi. 100 divided by pi, we're going to do a little bit of rounding here, is 31.83. And again, that equals r squared. And we don't want r squared, we want r. So to undo a square, we take the square root of both sides, and we get that the radius is 5.64 miles. And keep in mind, it's not miles squared because this is a radius, and a radius is just a length. It is not the area of anything, so we don't need to square it. Then we have the diameter of a circle with an area of 42 square meters. Well, formula is area equals pi r squared. We don't have a formula for diameter, so we're going to have to do that last little bit at the end. The area is 42 times pi r squared. We need to get r by itself, so I'm going to divide both sides by pi. 42 divided by pi is 13.37 equals r squared. And again, we don't want r squared, we want r. So I'm going to take the square root of both sides, and I get that the radius is 3.66. However, it does not ask what the radius is, it asks what the diameter is. The diameter is twice that, so the diameter, d, is going to be 3.66 times 2, which is 7.32. Okay, the area of a sector, again, is a proportion, just like when we did arc length. we did a proportion, we're going to do the exact same idea. One side of our proportion is going to be the angles. Okay, so one side is going to be the arc measure in degrees. Or just how many degrees is that central angle, that angle in the middle, out of the whole, which is 360. Okay, so this is saying how many degrees out of 360 is going to be one side. And the other side, now we're talking about area. So we're going to have the area of the sector, that's the part. Okay, that's like the piece of the pie, over the area of the whole circle. And the area of a circle we know is pi r squared. Okay, so again, this right here, we're going to keep coming back to how we can set up the proportion, which pieces are missing, and what information do we know. Okay, it wants us to find the red sector and the blue sector. Well, the red sector, let's take a look at that one first. It's 70 degrees. Okay, so we know that that is 70 degrees out of 360. That's going to be one side of our proportion. And it wants to know the area of that sector. Well, that we don't know, which is going to be x, divided by the area of the whole circle, which is pi r squared. Pi r squared in this case is going to be 8 squared, which is 64. Okay, so then we're just going to do, it's a proportion, so we're just going to do a little bit of cross multiplying like we did before, the butterfly method, however you want to think about that. So we're going to multiply like so. We get 360x equals, and then if we multiply the other way, 70 times 64 pi, 70 times 64 is 4,480 pi, because pi hasn't gone anywhere. And then we just need to use our calculator and divide both sides by 360. Okay, 4,480 divided by times pi divided by 360. Make sure you're doing these in your calculator. Don't just let me do all the work here, but actually put it into your calculator, and you should get 39.1. It should be in inches squared. There we go. The blue sector. Well, how do I know how many degrees that blue sector actually is? Well, I know a whole circle is 360 degrees. And the red sector is 70, so I know that the blue has to be 360 minus 70, which is 290. Okay, so I know that my blue sector is 290 out of 360. Okay, so my blue is going to be 290 out of 360 equals the area of the sector, I don't know, over the area of the whole circle, which is pi. And again, it's the same circle, still has a radius of 8, pi r squared. 8 squared is 64. And then we're just going to cross multiply again. We get 360x equals, if we take 290 times 64, we get 18,560 times pi, because that pi is still there. To get x all by itself, I divide both sides by 360, and again, putting it into the calculator, I need to make sure that I'm doing that correctly. If I take 18,560 times pi divided by 360, I get 161.97. What are we in? We are in inches, so that would be inches squared. Okay, so again, just thinking about what we know. Again, I'm going to put my little thought bubble down here. Okay, remembering how we set up that proportion. Remember, one side is degrees out of 360. It's going to be how many degrees is what's the measure of the arc? Out of the total, which is 360. And then on the other side, again, we have what is the area of the sector, that's the part, divided by the area of the whole circle, or pi r squared, depending on which one we need. Okay, so we have that down there. So I have one side, I'm going to find the area of the whole circle. I'm finding the area of circle H. That's the whole circle. So what do I know? I know I have an 85-degree angle out of 360. And I know the area of the sector, that red there where it says 214.37, that red says that's the area of the red part. So the area of the sector over here is 214.37. What we want to know is the area of the circle. We don't need to know the radius because the whole area of the circle is the denominator over here. So we can just call that x. If I do a little cross multiplying, I get 85x equals 214.37 times 360, which is 77,173.2. And then if I divide both sides by 85, okay, and notice there's no pi anywhere in this right now because we didn't actually have to use that, didn't have a radius and anything times pi. So we would get x equals, if we divide 77,000 divided by 85, I get 907.92. And since we are finding the area of the circle, it'd be 907 centimeters squared. Okay, now we have an interesting looking shape. Over here we need to find the area of it. And what we have over here is a semicircle and a triangle. And if we want to find the area of the whole thing, we need to add those two pieces together. So essentially what we're going to find is the area of the semicircle, and we are going to add it to the area of the triangle. When we get those, we just add them together and we have the whole thing. Well, if we want to find the area of a semicircle, okay, the area of a semicircle, remember, is half of a circle, which means the area of a whole circle is pi r squared, but we don't want the whole circle, we only want half of it, so I'm going to divide that by 2. That's going to be my semicircle. Then I'm going to add it to the area of a triangle. Area of a triangle is just half the base times the height. Okay, that's a formula that we've learned in years past. Okay, so let's look at the semicircle. Okay, I have a semicircle here. My radius is not 7, my diameter is 7, which means my radius is 3.5. So when I figure out the first part here, I'm going to have pi times 3.5 squared. But I only want half that because I want the semicircle. Plus, now I'm going to look at my triangle here. The triangle has a base of 7 and a height of 7, so I'm going to have 1/2 of 7 times 7. That's my base, that's my height. 3.5 is my radius. Okay, so if I do this, again, it's a lot of calculator work here, which is kind of nice. If I do 3.5 squared times pi divided by 2, I get 19.24. So that's the area of the semicircle. Plus, my triangle is 7 times 7, which is 49, divided by 2 is 24.5. So when I put those together, because I basically have a semicircle and a triangle I'm putting together, I get 43.74, and the area is always squared, so it's going to be meters squared. All right, last thing here is, looks like a toilet paper roll, a bullseye, whatever you happen to think, but we only want to find the area of the shaded part. which means basically we are going to take the area of the whole big circle and we're going to subtract out that middle piece. So we're going to have, basically we're going to have the area of the big circle minus, because we're going to pull out, we're going to subtract and take out the area of the small circle. Okay, sometimes it helps to think about it in words, what you're actually doing. So my area of my big circle here is, it has a radius of 24. So if you see that, it actually does go from the center of the big circle all the way out. So the area of the big circle is going to be pi r squared. So I'm going to have pi times 24 squared. I'm going to subtract the area of the small circle. The small circle has a radius of 6. So I'm going to have pi times 6 squared. And 24 squared, I believe, is 576. So we have 24 squared is 576 pi. Okay, that pi is still there. Minus 36 pi. Okay, and since they're like terms because they both have pi in them, I can just say 576 minus 36 is 540 times pi. So that's what I get when I subtracted out the middle part. Now I just need to actually put pi in for that. So 540 times pi is 1,696.46. And again, what's my label? Meters squared. Okay, so here's the second part of your week for this week. So you've watched, hopefully have watched 11.1, done the practice, done the big ideas. Now you have, this is the video for 11.2. There's again a short practice worksheet and a big ideas assignment for that. And then once you've worked through all of this stuff and you're ready for your demonstration of mastery, you open that assignment in Schoology, make a video through EduCreations. It shows all your works, all your steps, verbal explanations, all of that stuff. The demonstration of mastery is only 3 questions. So again, make sure you know how to use EduCreations and stuff too, but it's only 3 questions that you need to actually do. And the only thing that needs to be submitted for a grade for this entire week that I am going to grade is the demonstration of mastery through video through EduCreations. The rest is just preparation and practice. And if you do not submit at a proficient level the demonstration of mastery video, you get put in ICU and then you have to go back and do it again. So make sure you're doing it thoughtfully and doing it well the first time, please. Good luck and have a great day.